Hi everyone, myself Anirban, welcoming all of you to beta classes. So our today's topic is vector product or cross product. In the lecture scalar product, I have told you that there are two types of products or multiplication in vector. One is scalar product and another is vector product. This scalar product is also famous as dot product, and vector product is also known as cross product. If you haven't watched my lecture of scalar product, please go and watch. So our today's topic is vector product or cross product. As we have known that the scalar product is represented as a dot, now we are going to know that vector product is represented as a cross symbol. So assume that here is a vector A, which is A I cap plus B j cap plus C k cap, and another vector B, which is A2 I cap plus B2 j cap plus C2 k cap. Now we are going to solve a vector product of vector A and vector B. So it will be represented as A vector cross B vector. Now the formula of A cross B is mod A mod B sin theta. In the lecture of scalar product, I have told you that A dot B is represented as mod A mod B cos theta. This lecture I am showing you that A cross B is represented as mod A mod B sin theta. That's very important. Here is another representation of A cross B, which is also known as determinant, which is represented as this symbol. Suppose this is A vector, which is represented as A1 I cap plus B1 j cap plus C1 k cap, and B vector, which is represented as A2 I cap plus B2 j cap plus C2 k cap. So we can also write it as A vector cross B vector, that is equal to I cap j cap k cap, and A1 B1 C1, put these three values as A1 B1 C1, and A2 B2 C2, put it as A2 B2 C2. Now the question is how to solve this determinant. In mathematics, you will face a complete chapter of determinant and matrix. There you will solve different kinds of numericals on this topic. But here I am explaining determinant as per the requirement of physics. Now we are going to open this determinant. So at first you should put a positive symbol here, then negative, and then positive. So when you are going to open this determinant, you should consider as this row and this column are not present in this situation. As I am putting here, as this is here plus, so plus I cap, so I cap. Then you should consider that this row and this column is absent here. This row and this column. Okay, so the remainings are B1 C2, B2 C1. So multiply diagonally. So it will be B1 C2 B1 into C2 minus B2 into C1. Okay, B2 into C1. Then put a minus sign and J cap. At this situation, you should consider that this row and this column is absent. So the remainings are A1, C2, C1, A2. This row and this column is absent. Okay, this row and this column. So the remainings are this one, this one, this one, and this one. Okay, so it will be multiply diagonally. So it will be A1 C2. Okay, A1 C2 minus A2 C1. Okay, and at last plus K. Okay, plus K cap, and in this case you should consider that this row and this column is absent. This row and this column, this row and this column. Okay, so the remainings are A1 into B2. Okay, A1 into B2, A1 into B2, A1 into B2 minus A2 into B1. Okay, this row and this column is absent, so the remainings are A1 B2. Okay, and this one. So A1 B2 minus A2 B1, A2 B1. Okay, so this is when we have opened this determinant. So it will be such kind of way. Now you have to remember some important points about vector product. That is, number 1, A cross B, A vector cross B vector, that is equal to minus of B vector cross A vector. Okay, A cross B, that is equal to minus of B cross A. Okay, number 2 is the area of triangle bounded by vectors A and B. That means the area of triangle bounded by vectors A and B is half of mod of A cross B. Okay, half of mod of A cross B, half of mod of A cross B. So I am representing A vector as this, and this is your B vector. Okay, this is your B vector. So the triangle formed as such a way, so the area of this triangle is considered as half of mod of A cross B. That means at first you have to calculate the value of A cross B. Okay, then find the magnitude and then divide it by 2. So you will get the area of the triangle. And number 3 is, if you are getting the cross product of two vectors as 0, that means A vector cross B vector, that is coming out as 0, then always remember that the two vectors are parallel or anti-parallel with each other. Then the two vectors are parallel and anti-parallel, parallel or anti-parallel to each other. Okay, if the cross product of two vectors is coming out as 0, then these two vectors are parallel or anti-parallel to each other. Parallel means, suppose these two vectors are parallel with each other, okay, and anti-parallel means this A vector and B vector, these two vectors are anti-parallel with each other, as here the angle between A vector and B vector is 180 degree, and in this case this is 0 degree. In another approach, A cross B, that is equal to mod A mod B sin theta, okay, and A cross B, as these two vectors are parallel or anti-parallel with each other, so it will be 0, okay, the cross product is coming out as 0. So we can say that sin theta, that is also equal to 0. So when the value of theta is 0 degree, theta is 0 degree, then the sin theta will be 0, okay. When the value of theta is 180 degree, then the value of sin 180 degree will also be 0. That is why we are saying that when the cross product of two vectors are coming out as 0, then these two vectors are parallel or anti-parallel with each other. So you should remember these 3 points. This is the time to solve some numericals. So question number 1 is, so that the vector A, that's equal to I cap minus j cap plus 2k cap, is parallel to a vector B, that's equal to 3 I cap minus 3 j cap plus 6 k cap. So I have told previously that if the cross product of two vectors is coming out as 0, then the two vectors are parallel or anti-parallel with each other. So according to that statement, A cross B, that is equal to I cap, j cap, k cap, and 1 minus 1 2, and 3 minus 3 6. So I am opening this determinant, so it will be I cap 6 minus 1 6 minus 3 into 2 6 and minus, okay, then minus j, and 6 1 6 minus 6, okay, plus k cap, so it will be minus 3 and minus of minus 3, then minus 6 plus 6 minus j cap 6 minus 6 plus k cap minus 3 plus 3. So here plus minus will cancel, plus minus will cancel, and plus minus will cancel each other. So it will be 0 I cap minus 0 j cap plus 0 k cap. That means the result is coming out as 0. So according to the statement, the cross product of these two vectors is coming out as 0. So these two vectors are parallel or anti-parallel with each other. As in this question, we have to show that this is parallel, so these two vectors are parallel with each other. Now I am going to solve this question in another way. So the another approach is, here A vector, that is equal to I cap minus j cap plus 2k cap, and V vector, that is equal to 3 I cap minus 3 j cap plus 6 k cap. Look it very carefully. B vector, that is equal to, if we take common 3 from this vector, then it will be I cap minus j cap plus 2k cap. Okay, so v vector that is equal to thrice of, now look this vector very carefully, I cap minus j cap plus 2k cap. This is also vector A, I cap minus j cap plus 2k cap. So this vector is vector A. So v vector that is equal to thrice of A vector. Okay, that is why we can say that these two vectors are parallel with each other. Understood? You can also write it as A vector that is equal to 1 by 3 of B vector. Both of these are same. So this implies that A vector is parallel to B vector and magnitude of A is 1 by 3 times of magnitude of B. Okay, hence we have proved that A vector and B vector are parallel with each other. Here is another problem. The problem says, let a force F be acting on a body free to rotate about a point O. Here is a point O and you are applying this force to rotate this object or this particle, and this is the position vector R. So let a force F be acting on a body free to rotate about a point O, and let R be the position vector of any point P. Suppose this is P on the line of action of the force. Then torque, that is represented as tau symbol, of this force about point O is defined as, you will know this formula in rotation chapter, that tau vector that is equal to R vector cross F vector. Now our motto is to solve cross product or to learn cross product. That's why learn this formula, that tau is equal to R vector cross F vector, and it is given that F vector is 2 I cap plus 3 j cap minus k cap Newton, and R vector is equal to I cap minus j cap plus 6 k cap meter. So now you have to solve this cross product and to define the value of tau. So let us begin. It will be I cap, j cap, k cap as usual, and here the values are 2, 3, sorry, at first is your R, so it will be 1, minus 1 and 6. So 1, minus 1 and 6, and the value of F is 2, 3, minus 1. So 2, 3, minus 1. Check it once again. The value of R vector is 1, minus 1 and 6, and this is 2, 3, minus 1. Fine. So let us open this determinant. So it will be I cap, then it will be 1 minus 18 minus j, 1 and minus 1 and minus 12. Okay, and plus k cap 313 minus of minus 2. Okay, so it will be I minus 17 minus j minus 13 plus k cap 3 plus 2. So it will be minus 17 I cap, and this will be your minus minus plus, so 13 j cap and plus 5 k cap. So the value of tau or torque, it will be minus 17 I cap plus 13 j cap plus 5 k cap, and you should mention the unit also. It will be Newton meter. This is the unit of torque, Newton meter. So This is your answer. So that's all for today's lecture. Hope you have understood vector product or cross product very well. See you in the next lecture. Take care. Goodbye.